Welcome to EDU World Space.
Hello and welcome to another educational video brought to you by Numerade. My name is Ryan and today we're going to go ahead and look at how to construct an energy level diagram for lithium 2+. To start out with, I'm going to give a brief explanation of our diagram here, and then I'm going to go ahead and finish the construction of it. I currently have the general shape of one drawn out. And what these energy level diagrams do for us is they help us conceptualize the energy levels of an electron within an atom. And our electron is free to move in between these energy levels, but it only does so, it only moves up if we absorb any energy. And when it moves down, we give off energy from our atom. And typically the energy we give off is light. And typically the energy we absorb is also light. Something important to note about this is that we can move up and down between these energy levels as we absorb light and give off light. However, typically the only shifts that we have is from the ground state, our n is equal to 1 state, up to some energy level, or from some energy level down to our n is equal to 1 or our ground state. And then again, our single axis over here is energy. And then these n is equal to 1, 2, and 3, 4, 5, etc. denote our energy levels. There is an infinite amount of energy levels, which I'm just going to denote as a squiggly line. For today's demonstration purposes, we're only going to be looking at the first 5. So let's go ahead and figure out how we actually find the numerical values for the energy at any one energy level on this graph. And to do that, we need to find an equation. And to find that equation, I'm going to first talk about the similarities between lithium and hydrogen, because we've already solved for the energy levels of the hydrogen atom. And if there's enough similarities between our hydrogen atom and our lithium atom, we're going to be able to go ahead and use that equation from the hydrogen atom and apply that to our lithium atom. So if we look at our lithium atom, we have 3 protons in its nucleus and some amount of neutrons. I'm not going to draw those in because they do not affect our calculations. And we have a singular electron orbiting our lithium. Whereas over here in hydrogen, we have a singular proton and a singular electron orbiting our proton. And now, because both of these atoms only have 1 electron orbiting the nucleus, we know that there's not going to be any interference from any other electrons affecting this electron over here in our lithium atom. So we can actually go ahead and use the equation that we used to solve for the energy levels in our hydrogen atom, because there's enough similarities and because all of the calculations we did to solve and make that equation for our hydrogen atom also apply for our lithium atom over here. And that equation is E sub m, our energy level, is going to equal negative 13.6 electron volts multiplied by Z squared divided by N squared. And Z is going to be the number of protons in an atom, and N equals the energy level. All right, so we go ahead and look at the first energy level of our lithium atom. That is going to equal negative 13.6 electron volts multiplied by Z, but in our case, Z is equal to 3, and that is squared divided by n, which in this case is 1. And that ends up equaling 122.4. It's negative, of course, electron volts. And that is our first energy level. And then we could, of course, go ahead and solve for our second energy level. We'll actually make that into a 2 instead of an n. And that's going to be negative 13.6 electron volts multiplied by 3 squared, or z, divided by our energy level, which is 2, squared. And that ends up being negative 30.6 electron volts. And then to complete our diagram up here, we go ahead and plug in those energy level values here and here. And to fully complete it, we would calculate our n is equal to 3 energy level numerical value. Same with 4 and 5. And for the brevity of our video today, I'm going to go ahead and leave that as an exercise for the reader, or viewer rather. And I'm going to go ahead and leave this equation up for the end of the video for your reference. Alrighty, thank you, and